Chapter 12, Principles of Pharmacology. So the introduction for this is really about administering medications and how serious this is. This is one of the largest potentials for harm to a patient if we misappropriate or misuse a medication, or even give the wrong medication for the wrong diagnosis. So believe it or not, medication administration errors actually contribute to tens of thousands of deaths across the US in hospitals alone. I'm not sure if there's a significant study that's been done on EMS where its impact is people's lives, but safe medication administration is really the key principle here. And so we're going to discuss some pharmacology and how those medications affect the body. Those who do not understand how the medication work are dangerous to themselves and to the patients. And by dangerous to themselves, that means like if you don't understand that you can absorb nitroglycerin through your skin, or if you inadvertently spray it in your face, you can cause yourself potential harm. And we certainly don't want to injure our patient by giving them the wrong drug for the wrong reason at the wrong time. Drug profiles. Drug profiles are kind of grouped into certain medication classes. This is how you're going to easily identify a medication based on its actions. The terms drugs and medications are often used interchangeably, even though we typically think of the term for drug as a recreational concoction that people might use. Really and truly, drugs and medications are kind of the same thing. We want to make sure that we're using the word medication with your patient, because using the wrong terminology with the wrong patient, you may offend them or they may become confused. If you ask them if they're on any drugs, they may take that as a recreational drug and not a medication. But if you use the term medication, it gives it the look of acceptance, or it clarifies that this is not illicit and more prescription. Some of the terminology you need to know with medications and pharmacology are dose. And by dose, that means what is the actual volume or weight of the drug that is being given, such as milligrams or mLs. And then the action of the drug, and then we're looking for unintended effects and then untoward effects. And unintended effects is really we give a medication and we did not mean for something to happen. And then the untoward effect is kind of a negative action that's going to arise from the use of that particular drug. Toxicity is really determined by how much of this drug can be tolerated in the body before it has really negative effects as far as homeostasis and whether or not it turns into a poison. And then indications and contraindications, and it's pretty self-explanatory. If it's indicated, that means that you are being given clues or reasons to use a drug, and contraindications is the reasons that you would not use a particular drug. Most medications, if not all, have 4 names. The first being the trade name, and in the example here, this is Vanseril. Another one would be Tylenol. The generic name on this one would be the example of beclomethasone, and then dipropionate, and we can translate that over to acetaminophen. Then we have a chemical name, which has the chemical formula and how it was derived. This is quite literally, if you've taken chemistry, how the drug would lay out in a diagram and where its carbon chains and other components are sitting. And then the official name, which is what the FDA and the government uses to track, both of which I really don't have an answer for you as far as the chemical composition of Tylenol, and the official name for Tylenol would be Tylenol or acetaminophen. So medications licensed for use by the United States are listed by their generic names, which again, in this particular case that I'm using is acetaminophen. So more often than not, you're going to encounter patients who are taking prescription medications or over-the-counter medications. Sometimes we're going to encounter people that are using street drugs or prescription medications that are being used for recreational purposes, and then herbal supplements. And we really want to remember most of this, because some of these drugs can have interactions with other drugs, and certain herbs or other over-the-counter supplements can actually interact with drugs or block their effects. So becoming more and more familiar with that is kind of a challenge. It comes with experience and a lot of dedication to reading and just the repetition of it. So you'll see as you go further in your career, the more that you're asking questions, you'll hear the same common names come up for certain ailments, and these are things that will kind of help you base your treatment algorithms based on past medical history. So places that you can actually do some research to figure out certain things about drugs is the AMA Drug Evaluation Book, the Physician's Desk Reference, which is a very hefty book. You can get it on CD-ROM apparently, or I'm hoping in 2020 you can just download it, as I don't know many computers that are still using CDs. The FDA has a Drug Evaluation and Research Center, which also deals with many of the drugs that you can look up and see what the research studies say and what their findings were. Other publications that you might determine to use are going to be the hospital formulary or drug inserts or pamphlets. Sometimes the drug inserts and pamphlets are going to be stored with a patient's medications so that they have them. Hospital formularies and even our drug guidelines for the state or our local protocols, or as guidelines as we call them, are now available to just about anybody. Make sure that you're always using a reputable source, because there are other texts and sources on the internet, and with the advent of the internet, it's wonderful. There is information freely at the touch of your fingertips. Not all of it is reliable, so make sure that you're using a trusted source if you're trying to do research on a particular drug and you want the latest, most up-to-date information. It's really easily had, and unfortunately really easily to get, or I should say really easy to get bad information as well. Medscape is an approved, excellent free reference, and you can use any of your smartphones to access that. The manufacturer of pharmaceuticals is subject to all kinds of laws and regulation. The FDA is really stringent about the way medications come in and out of people's hands in the United States and the process that's used to approve them. So there are drug standards that are published in the National Formulary, and this is really to protect the end user or the consumer. Right? We never want to have a medication that has unintended consequences that we've not really fully vetted out, to where we might cause undue harm or death to somebody when we're in fact trying to treat something to make them better. So there's some pretty good legislation that has occurred over time that's created the current situation today, and one of those was the Pure Food and Drug Act. That was in 1906, and it basically just required that you would label what was on a particular compound that you were selling for drugs. The Food, Drug, and Cosmetic Act of 1938 made it mandatory that we would symbolize or signify or allow for people to understand that there's habit-forming substances and side effects that have to be on the labels. And then this also created the FDA, and now any drug that is deemed dangerous, whether or not realistic or not, requires a prescription and may be regulated to a point where it's not allowed to be used federally. The Harrison Narcotic Act of 1914 regulated the import, manufacture, prescription, and sale of most narcotics, obviously not the illicit drugs. The Narcotic Control Act of 56 outlawed those illicit drugs like heroin and the transportation of marijuana. Continuing on with the Controlled Substance Acts, that's comprehensive legislation dealing with drugs for potential for abuse. And this is done by legislators, not necessarily scientists or doctors, and the drugs are classified into 5 categories based on what the perceived potential of harm is for their abuse. Schedule 1 is the highest abuse potential, and that means that there is no accepted medical application. And so in this particular case, it's heroin, which again is a derivative of opium, which is found in many of our opiate drugs that we actually give. LSD, which is lysergic acid, and then we have the marijuana, which in this slide is kind of out of date. There are many states that have enacted that marijuana has a legitimate use in medical treatment, although not federally approved. There are many states already in the U.S. right now that are allowing patients to use this for treatment of pain and other potential illnesses or injuries. Schedule 2 is a very high abuse potential, and for example, they're using that as opiates and cocaine. Now notice it was not necessarily heroin or something like that, but OxyContin or any of your oxycodone or Percocet would fall into that. Cocaine, obviously, there are a few medical uses for that. One of them would be like nosebleeds. and certain things where we want to control bleeding or some kind of pain in the facial area. But it's due to its fact that it's abused quite often in the illicit drug trade. It is a Schedule II drug. Schedule III says that it may lead to a low or moderate physical but high psychological dependence. And so that would be Vicodin, Tylenol with codeine. And these are, extra supplements to certain drugs where we produce that kind of habitual formation, and then the body responds accordingly when you just try to stop utilizing that drug. Schedule IV is going to be something along the lines of Valium or Ativan, which is our barbiturate class. Many people do become hooked on that, but there seems to not be nearly as much emphasis on getting somebody back off of that drug. It seems to have a lower risk of side effect. And then Schedule V is cough syrup containing codeine and other things like that. As you guys can kind of imagine, alcohol and tobacco, which are both completely legal in the United States, probably falls somewhere in the middle of these ranges, right? Probably a little bit more high towards maybe a Schedule II with tobacco. Alcohol has its own problems, but prohibition and outlawing these particular substances has not been affected, and they remain off the list. So federal regulation focuses on guaranteeing that there are standardized doses, and that means when you look at a particular drug, it's going to come in a dose of, we'll say perhaps Percocet or oxycodone, where these drugs would have a 2.5 milligram dose with a related, say, Tylenol dose of 250, 350, or 500. This is so that they're consistent across the board regardless of manufacturer. And for a drug to carry the USP label, the active ingredient has to be within a tolerance of 95 to 105% stated on the label. So if it says it has 2 milligrams, it has to be within 95 to 105% of 2 milligrams by weight of that particular drug in that whatever form it's being delivered in. Some of the government agencies that regulate drugs are the FDA and the DEA. The FDA is the primary regulator that allows whether or not that drug is in the United States for a legitimate medical purpose, and the DEA is the enforcement arm of that particular agency in regards to whether or not those drugs are being misappropriated or misused or used for illicit purposes, or drugs that are not approved for any medical use or to be used outside of those parameters. The Public Health Service regulates biological products, and then the Federal Trade Commission is monitoring drug advertising. So this is making sure that people are not making false claims to get you to request that particular medication, which may or may not do the required or intended effects. And as you guys are all aware, there are many, many loopholes, and if you call something a supplement and you're not actually calling it a medication, you can get away with a lot. In regards to an actual medication that's approved for medical use, they must go through the FTC, and all of their claims must be verified and backed up. The drug approval process is a constantly evolving process. The US tends to be a little bit slower because there's a lot of litigiousness to society here. Drugs will come out in other countries much quicker than what we get here in the US, and it takes on average about 9 years to get through the testing process. And so most of them will go through animal studies to see if there's any massive effects, and this could be all the way down to your non-sugar sweeteners inside of your soft drinks like saccharin and the like. They will go through an animal test to see if there's any really untoward or negative effects at differing dose levels, and then they're also looking for the intended effect in animals. The issue there is that animal studies rarely really translate to human studies very effectively, and so then they'll go through clinical trials in humans after they've kind of determined that there's no really readily apparent danger to a human being based on the animal model. So those animal studies are designed to learn more about the properties of the drug, and then it's going to identify tissues and organs sensitive to the drug's interactions. You have to use at least 2 separate animal species by law, because again, animal studies rarely translate over to humans in a very effective and efficient manner, but it is a somewhat of a predictor I mean, obviously, if you give a drug to a particular animal, and every time you give that drug to that animal, it kills it, there's a high likelihood that it may kill a human being. And so more often than not, they're using the animal study to make sure that there is at least a modicum of safety to it. Clinical trials start in a couple of phases, and in phase 1, that new drug is tested in healthy volunteers. This means that people understand that it is a completely new drug on the market. They actually are not in need of this particular drug. It's not something that they're taking under the undue stress of thinking that it may potentially save their lives. And then the effects are measured in that person who actually does not need to have that particular drug. And what they're looking for is whether or not it's going to create any kind of blood toxicity or kind of metabolic damage, and if it's in fact doing some of the things that it should be doing, and then where the doses are. And then they're really just looking to see how safe is this drug before we give it to somebody who's desperate for treatment. Phase 2 goes into the homogeneous patient populations, and this is really kind of looking at the efficacy and the safety of the drug again. We're really trying to figure out like what is the effective dose on that particular drug. So when you guys are looking at your drugs and your pharmacology guidelines, right, we know that because of the hepatic toxicity that acetaminophen can cause, that there's a safe and effective dose for pediatrics, that being 10 to 15 milligrams per kilogram, with no more than 50 milligrams per kilogram in a 24-hour day. And the reason for that is because as they studied and tested that, they understood that higher doses than that would cause irreversible liver damage, or liver damage that would take a significant amount of time to heal itself. And very few organs in the body are able to heal from a significant insult. Phase 3 is where the drug is made available to a larger group of patients, and this is where the crux of the matter really starts to begin. And this takes several years, and then they tend to end up doing double-blind trials, and they're looking to see what the nature and the incidence of side effects are. And the interesting thing about side effects is if one person just says that X effect happened to them, it may or may not actually be related to the drug, but now it has to be listed as a potential side effect, no matter how small or slight the potentiation is for that. And then phase 4, they apply to the FDA for approval, and then they compare that new drug with others on the market to see if that drug is necessary. So this might answer some questions with why is albuterol basically the only drug approved in the FDA for the US as far as like its mirrored counterpart in the European Union, which would be clenbuterol. And that's because the FDA says that with the drug albuterol, there's no need for another drug that's a derivative that doesn't necessarily improve upon its performance, and so there's no reason to actually come in with a new medication. The FDA classification of newly approved drugs, they are assigned a numeric and letter classification, and this is the type of drug that's being submitted and its intended uses. They're going to use new molecular drugs and complete new medications, a new salt of a previously approved drug, and then a medication derived from an existing drug. So that means that perhaps they have a drug that they alter its chemical classification. It becomes a new drug, but it was based off of the previous one. It is now going to have a new classification and its own FDA approval. So a new formulation of a previous approved drug is going to be something along the lines of something with APAP, right? Like Percocet with APAP. And that's really just using an opiate with a Tylenol in a combination so that you can approach pain relief from two different receptors because they're working on different pathways in the body. The combination of the two drugs creates a new need for classification. And then if the drug's already marketed, there needs to be a generic version after the patent expires. So in regards to this slide, you see the new indication or a claim for a drug that's already being marketed. And there are several drugs that are on the market that can and are quite often used off-label. One of those would be something like you may hear the term finasteride, which is used for benign prostate hypertrophy, and that's a thickening of the prostate wall, which creates urinary retention. This particular drug also was found to create hair growth in males who are experiencing male pattern baldness. It works in females as well, but there's some toxicity side effects that are undesirable for females, so it's absolutely not prescribed to females because of that. And then other things like Viagra, which was actually developed to be used as a blood pressure regulator, was found to create the unintended side effect of an erection in men. And so now it's literally used as a sexually enhancing drug instead of a blood pressure medication. So when these drugs switch back and forth like that, they need to have new classifications based on what they're using or what they're used for. And then often drugs will fall off of the prescription market and go to over the counter when they're so readily available and significantly benign in regards to the risk of the end user using that particular drug. If there's additional benefits found, that actually has to be classified, again, much like the finasteride or the Viagra. And then if there is a drug that is already marketed with no new drug application, but it's not classified,